All right. Everybody's here, right?
Yes.
Okay. So I've started the recording. So this is a very quick session to introduce you all to scripting, and this would be very helpful in automation, in writing something that you want to schedule on an everyday basis. So uh, this will be like an introduction session for you, and I'll explain some concepts and some basic commands that you might use in your scripts and how to write a basic shell script and how is it comparable with other languages as well. You can take this knowledge further and you can further read about more commands and as in when the need be. So whatever project you are working upon, whatever need you are working on, so and you can then specific to that you can search for your required commands and work on that. All right, so I already have one machine running on AWS. By the way, any of you have any idea about scripting? Have done it before? Have written any basic scripts? Okay. All right. So I already have a machine running. You can also launch a machine on your local virtual box, or you can launch a machine on your Amazon account, or also you have various other options available online. If you are not interested in launching machines, you can explore certain online compilers, as in, so there will be very various online shell script compilers available. So you can also practice your scripting knowledge on any of these available IDs. Okay. All right. So let's quickly start. I already have some notes created.
Um, can I ask you something?
Mhm.
So most of the time when you work, you sometimes they give it to you like a code is they're already working or something.
Hmm.
So when I was at working at State Farm, I was a developer, so they had everything in GitLab. So are
Mhm.
you gonna be able to show us a little bit how GitLab works? Just like a little bit version. I mean, are they gonna expect us as an admin to know that, or
So what happens is sometimes uh, in senior positions, if when you move on, they'll expect you to know about Git, Jenkins, and all that. And it's not it's a good thing to know these things, but from a developer's point of view, it's very compulsory because once you write your code, it's always required for you to commit that code to the Git. So okay, so let's take 5 minutes and let me explain you what exactly is Git. So Git is nothing but a centralized repository. Git is a centralized repository for your organization to keep the company's code. So any code that you guys work for any company, once you have written that code, they would expect you to commit that code. When I say commit, is basically you are submitting that code into a centralized place, and this make sure that that is available to everyone around you, around the company. Now, to give you an example, I have already a GitHub account created for me, and this is a desktop version of Git. So let me show you what exactly that is. So whenever somebody needs to work upon a code that's already present in the company's repository, the only thing the one has to do is to check out. So there are certain terms related to Git, checkout, or you can say it as clone. Then you have add files, add file. Then you have commit. Then you have push. So these are basic commands that one might need when somebody has to work upon a certain code that's already present in the company. Now, as an admin, if you talk of, there could be possibility that there are scripts present at a certain location in the GitHub. So you should know at least these basic uh, commands, these basic things, and how would you do all these things to understand that better. Okay, so for a normal Windows environment, they give this very good UI. You just need to copy that things in a particular directory from which this application will read. But on a Linux environment, what happens is you need to manually do all these
Sahil, your
steps.
voice is breaking out.
Okay, one second. Okay, I think it should be clear now. So this is a normal Windows application for Git, what you see right now. And you can see something is already happening automatically by this application. It's refreshing my repository. And all these things, all the code that you want to, check out or push onto is basically present in a repository. So you can have multiple repository in your company's account. So right now, like this is an automation work that I'm already working on. It's a Cassandra automation, and I already have a repository available. Now you can see all the things that I was talking of. Push, pull. Pull is nothing but checkout clone. You can call it pull as well. So all of this is like a button away on this application. But once you are working on a normal Linux shell, all of this has a command associated with it. So we'll discuss in a quick fashion right now. But before that, I'll have to clone this repository onto my local. So let's just quickly see first of all how is the orientation of it. So this is, you might have also seen it on a public. So you there are various public repositories also created by various people wherein they have submitted their codes and everything. But this is an organization specific repository. This is the organization name, although it's a dummy organization, and I have created it so that I can keep my codes privately in here. Now, let's say this is a company's code that is already present over this uh, uh, over this URL. Now, to clone it or to get it first on your local system, what you have to do is, let's say I want to get this whole code into this Linux machine. So the command to use is git clone followed by the repository URL. Once you enter it, it will ask you for your username and password. Okay, so response time is a little slow. So it will ask you for your company's credential, and once you have got all those credentials, once you get that credentials into it, you will have this directory available to you onto your local system, just like how you see it right now. So you will see these three files. You will see a roles folder. This is basically a folder that contains all those codes. This is a Ansible based automation script that I have written, and this whole thing that you see being written is basically being read out from this file readme.md. So similarly, in your organization's your company's GitHub account also, if you are referring to a certain project, so this is when this is an account. Although I only have one project folder available in here, but you might see multiple such folders like this. So this is basically uh, a code that I committed into my company's account. This is a dummy company that I created. Apart from these, also you can see multiple such code repositories. So this is basically a repository. And once you run this git clone command, you will be able to get all these files onto your Linux system. Now, next thing is if you want to change anything into these files. So once you have it onto your local, you can go into a certain file. Let's say I want to change something in this file. Okay, so you can do a VI once you have this file available on your Linux. Just VI. I think my shell has struck. So you just need to VI that file, make your changes. So let's say I want to change this name and I want to convert it into a certain different name. So I'll change this name and I'll run another command. So once you change any file, they will start appearing as a change file. So git status is one command that will show you. For example, I might have some different repository in here. Yeah, this is a git repository right now. So when I run this git status, any changes that I make to any file, for example, if I change this readme, let's say, I make a change to this file, I save it, I run git status, it will show that you have modified this file. Now it's up to me that if whatever files that I have modified onto my local system, I want those changes to appear on this centralized place as well, I can do that. So for that, first of all, I need to add this file. So the command to do that is git add, then your file name. Once that is done, you'll do a git status. Now it's appearing green because you have added this change to be uploaded. Now the next thing is, once you have added it, is commit. What commit will do, it will create a branch. It will create a change that needs to be uploaded onto this folder. So next thing is git commit. Once I commit it, this will start appearing. This will go away from this place, and it will be available to push into this folder. Once you commit it, the next command would be, I'm not doing it because that would make those changes go into the file. Next thing is git push.
And there's another thing called fetch, right? That's exactly when someone else does any
Yeah.
change.
Yeah. So what happens is, like, let's say 4 or 5 people are working on the same repository. Okay. And they have made their own changes. And let's say all 4 of them downloaded the files at a timestamp. Okay. So you have 1, 2, 3, 4 people are working. All 4 of them downloaded those files at a certain timestamp, let's say 9 a.m. Okay. All of them downloaded at the same time, 9 a.m. Now what happens is the first person made certain changes and he uploaded those changes at 10 a.m. Now the second, third, and fourth person are not aware about these changes because they also downloaded the files when it was available at 9 a.m. So what they have to do right now is they will do a git pull. They might already have, since they already downloaded that file, that folder at 9 a.m. Any new changes that might have come up at 10 a.m. They would have to do a git pull, so that would refresh the current state of the file, and this needs to be done right before you are committing your changes because you don't want to get into any conflicts. Otherwise what happens is it tends to appear some conflicts. So this git pull is nothing but you are fetching the new files uploaded. You're fetching is actually you're fetching your the latest state of your git folder onto your local system. So that is the concept of fetch. And so similarly, let's say second person did at 11 a.m. So now all of these 1, 3, and 4 needs to download the new changes. So they will again do a git pull, and this will make sure that they are all in a sync situation. So what exactly the use of git, you can say, is basically you are keeping your files at a centralized folder onto one such server. So this is basically, this can be any, this is although a GitHub server, but in normal organizations they have their own private servers where they might be hosting this git. Okay, so yeah, you need to just keep that place. And as an admin you might need to, when you're working on automation or something, you might need to work on git, and the basic commands will be fine for an admin. So like basic commands that I talked of is git pull, git add once you want to add a new file that you changed. Then you have git status to check the status of the current folder. Then you have git commit and git push. This would be enough for an admin. But if you are a developer, there are various other commands like git soft reset, git soft and hard reset, and then you might need to do something like git merge when you have multiple branches. Okay, so what happens is you can have various other kind of branches. Right now this is a master branch. Anything that uh, if you want to do some CI/CD, continuous integration, continuous development automation, that will pick up the code from the master branch. But if you are working on some new changes, you can also create a new branch, uh, and work upon those changes while your master branch is updated with the current working code. And once you are sure that your other branch is fine enough to be uploaded to the master, you can merge those two branches so that the new automation code can work fine. So that's basically a very uh, advanced topic and mostly relates to the developers, but we are fine with these 4 commands. 4-5 commands. Okay, I think that explains about Git. And in continuation to this, you have various other tools: Jenkins, Ansible, Chef, Puppet. Chef, Puppet basically are from a Linux point of view, but they do add value. And I think, yeah,
Maven.
Yeah, Maven is for so Maven is once you're writing your code. So Maven it's basically a repository. Uh, repository for jars and everything, I think. And if it's for basically automatic compilation of your code and Maven, both of them. So that's also from a developer's point of view. But from an admin or from an infrastructure guy, these things might be your interest. Jenkins, Ansible, Chef, Puppet, and definitely scripting is imbibed in every of these concepts. For example, in here, if you see, this is an Ansible code, and also I might have include some Python scripting. Python or shell scripting, I think. So, for example, I've created this script.sh to create certain certificates, SSL certificates. So all of these scripting will be like used depending upon your need in all of these tools. All right, I think let's quickly start with our concepts of scripting now. Okay, so first of all, what exactly do you think is a script and why do we need it? The script is nothing but a sequence of various commands and steps that you want to execute onto a server. Instead of writing it on an interpretable screen like this, every command, let's say I want to go Sahil, after that I want to create a variable, after that I want to echo the value of the variable. So all of these things, since what I am doing is step by step, I am printing those commands. Instead of that, what I can do is I can create a file and I can write all of these steps within that file. And then I just need to run this file and all of these steps will execute automatically one by one. So scripting is nothing but a sequence of steps, and as we discussed about Git also, so all of these commands that we might have been doing, git pull, git add, by step, you can also place such commands into your script files. So scripting is a way of organizing your steps. It could be related to anything. It could be a git, it could be just like these YAMLs. So right now, if you want to run, I created this Ansible code, and if you want to run this code, so this is a step, for example, to run a Ansible script. Now you could have also place this command within your shell script. So it's a way of organizing. So what you could have done is you could have first of all git clone. So this command would have come into the file, script file. After that, you would have done some changes. You would have uh, before adding and pushing, before adding and committing those changes, you might have run this playbook to check if it's working fine. And depending upon the status, you could have added those change files and you could have committed it into the Git repository. So it's on a basic sense, any command that works on Linux, you can organize it in a particular file so that when you run that file, all of those commands are executed sequentially. Okay, so it cannot be that any command that's present at the bottom of the file will execute first. It will always execute from the top of the file to the bottom, and any of the variables that are expected should come up first into the file. For example, if this variable var was expected here, but I am describing it below it, so this won't work. Before using this variable, I need to define it because it always executes from tops to bottom. All right. Okay. So once it's connecting with the Amazon, let's just talk about some basic Linux things. Okay. So normal shell script ends with a .sh, as you might have seen in this file. It's not a compulsory thing, although I could have done something like, instead of using a .sh, but it makes things more clear. I could have done something like a normal file, and even that would have worked fine, like this. So it doesn't matter whether you are placing a .sh at the back end or not, but it makes things a little more clearer to the shell that you're actually executing a shell script. Similarly, if I would have to write a Python script, it ends with a py extension. So it makes the understandability a little easier for you as well as for the compiler. Okay. Now, other important thing to know about any script is the first line. First line usually starts with these two characters. They are known as shebang. Okay, so shebang character followed by the type of script you are working on. So right now this is a shell script, so I have given the path of the shell executable. If I would have been working on a Python script, I would have given a path of the Python executable. Okay. So the first line determines what kind of a script you are writing. You could have, like earlier I was not using that line, so even that is fine. In that case, you will have to provide something like the executable at the time of run. But if you are giving the executable right in the first line, you could have also run this script like this, but it would ask for you some permissions, although it didn't ask because this is a Windows environment thing. This is a Linux interpretation of Windows, but otherwise it always asks for a executable permission. So you always provide it a executable permission to this file, and after that you could have run it like this also. And how now this, I'm not, even though I'm not providing the type of executable, how does it interpret what kind of a executable it is? that it is a shell executable, it's basically interpreting that from the first line that starts with a shebang character. Now, another important thing to know about scripting is the comments. So, if you just place a hash like this, anything that's written after it is basically a comment. All right. Now, after this, okay, so these two things are now clear. Any script should end Python or shell. Traditional Linux scripting employs shell. So basically, earlier people used to work on shell scripting now, but you have various other alternatives, and Python is appearing as a very good alternative to shell because it's easier to learn and it has some other object-oriented programming options also available. Okay, Python is also an interpretable language, but one must know about the shell scripting because Python also has evolved from that only, and uh, shell commands are always useful, and sometimes it's better to use a shell command rather than a normal Python command. So it's good to know about all these things. Okay, and a shell script is a file that ends with .sh. I've already talked about it. First line is a shebang, specify the shell path. Uh, we also need an executable permission to run. So the reason I have connected to a Linux instance is so that I can make you understand how exactly. Okay, so as we talked of these two things, now the next thing is how do you read a variable from a user input? Sometimes what happens is that you might want to uh, be specific to a user that's interacting with your script. For in this case, let's say if I want to print the name of the person who is right now interacting with the script. So instead of just writing hello followed by a hard-coded name, I would ask that person his name and then only I would print the stuff. So this can be done using a variable known as read. This might also be useful in scenarios wherein uh, you know so let's say there's a scenario that you want to execute a script that's dependent on some other script and the value that is being generated from that. Let's say there are two scripts. So script one outputs a variable out which can have values success, fail, halt. Okay. Now depending upon any of these values, you have to run the another script S2. So how would you interpret which so let's say this script 2 has inbuilt a function which will run any of the modules. So you have a module for the success, you have a module for failure, you have a module for halt. Now, determining upon which kind of a module you want to run, you can declare a variable var that will always be read from the output of the first script. So to do that, So whatever is will be the output coming out of this script one as a variable out will be inputted to this, or you can call it readout in here. So depending upon this value, your corresponding module of the script will run. So this kind of thing is very useful when you are working on continuous scripting kind of stuff, or whenever also when you are making something like a user interactive, that would also be good to use. So a variable known as read is used to read the value associated. So for example, when I run this script now, it will ask me for my name because I have, and it will wait for me to enter that. Until and unless I don't enter it, the script will keep on being in this state. As soon as I enter my name in here, so don't read about these 4 lines, just read about till here. So it, as soon as I entered my name, it ran with the other steps of the script. It has printed out the name after the hello keyword. Similarly, if I would have given some other name, so it would have printed out that name. So this variable is now dependent upon whatever value that I pass in. Okay. Now, after this, comments is done. Okay. Okay. Now let's talk about variables and what exactly they are. Now, variable is nothing but a container of the script or of your shell also. So normal Linux, you can create any kind of variable that holds certain value. So let's say this is a variable var that holds a value 4. Okay, so I could have, now this will persist until and unless I don't exit my container, my shell. So this value will always be hold 4 will always exist in the variable var. Now if I want to read the value of what exactly is holding in this variable, I always have to use a dollar sign followed by the variable name, and it will print out the value that is being holding into this variable. Now if I want to change the value, so this is basically a container. Variable is nothing but a container. It can hold any values that you want. If I want to change the value, I will do something like this, and now you can see that the value changes. I can use this value anywhere within the script also. Now there are certain rules associated with what and how variables you can create. Basic things are, it must include characters and numbers, smaller or greater, capital letters or lowercase, or numbers. Apart from these 3 things, you cannot use any other character. So these kind of character cannot be used in the variable name because they have some special meaning. As I told you about dollar, so dollar has a special meaning associated with variables. It helps to print out the value. So that's why you cannot, use this character when you are naming your variable. You can also use a underscore apart from the characters. Underscore can also be used, mostly because when you are segregating out a logical name, uh, for example, if this would have been written continuously, it would not make that much sense by instead of using a underscore between it. So that's why they have included underscore within the naming of the characters. Also, it's always recommended to use capital letters. Variables are always written in capital letters, although it doesn't matter. You can have, the shell won't uh, punish you for making character variables in smaller lowercase characters, but it's a normal industry norm to write variables in capital letters. Also, you can see that a capital var is different from a lowercase var, so variables are case sensitive. Okay. Also, as I told you, how do you assign values? So you have to use a equals to sign, and after that you have to give the value. Now there is a catch in here that it doesn't work like this. So there has to be no space in Linux in shell scripting. Although this could have worked fine in a normal Python script, but on a Linux shell, it always gives you an error. So make sure there are no spaces between the variables. Okay, now how to access the value. So as I told you, $sign is used to access the value. Echo is a command. Okay, echo is the command to print out the value that is being contained to this. Otherwise, what I would have done is I would have used this value in some other place. And whenever I want to use the value contained in a variable, I always has to accompany it with a $sign. Okay, now as you can see that I changed the value of this variable, which earlier had a value 4 to value 5. You could prohibit it by using another keyword known as read only. As the name suggests, whenever you make a variable, so right now this variable has a value 5. If I make it read only right now I cannot change its values to some other. So as soon as I have to do var equals to 4, it says that this variable is read only and its value cannot be altered. So if you are working on certain variables that you don't want anyone to change, so this will always have a value 5 and nobody can change it. Also, there is another keyword known as unset. As the name suggests, it will unset the value associated. So right now, since we made this variable read only, even the unset won't work onto it, but unset might work on some other variable that is not read only. So this variable that has had a value equals to variable will become unset as soon as I run this command over it. So now it has, sorry, now it has no value associated. It's like an empty container now. Okay. Okay. Now there are certain special variables. These are mostly, many times people ask them in interviews also. So these are certain special variables associated with Linux. For example, $, this will print out the process ID of the current shell. So this shell that I am working on right now, it actually has a process ID 1847. Now there is another variable dollar followed by this character, negate character. This printouts the process ID of the previously executed background process. Now right now I don't have any background process that I ran earlier, but let's say I run a background process. Let's say I ran a process name echo my name at the background. Now how do you make a process background? By this character. This character will make sure that the process will run at the background. Now you can see that it This was the background process it ran and had a value 1893 in the background. Now if I run echo, and once it's done, it has printed out that my background process has completed. Now if I now print this echo dollar negate character, it prints out the process ID of the previously executed background process. So let's say I run this again, and now this time it has a background process ID 1894. This variable will change its value to 1894 as well. So every time you're working on a Linux and you are curious to know, or you want to understand, it might be required in your scripting also, that you want to make sure that a process that's running in the backend has completed, then this variable can come into effect. Then you have a variable dollar question mark which prints out the exit status. Now there are two kinds of exit status. One can be a success, other can be failure. Any number, if success, it will always be equal to 0, and failure can be any number other than 0. So all these processes that I ran, they all had a success, right? So everything was fine with these processes. So if I now run this echo dollar question mark, so I ran this process at the backend. This gave this value 130 because I didn't ran anything. I did a control C to exit this command shell, so that's why it was giving a failure exit code. But this rev command ran fine, and that's why the exit code of the previous command that ran had value 0. Now let's say something went wrong. It said command not found, so this ran into a failure. Now if I run an echo dollar question mark, it will have a certain other value than 0. So this will make me understand that my previous command that executed didn't ran fine. And depending upon this information, I could write down some other sequential command. Then you have certain variable specific input variable specific special variables. So let's say if this script that I'm writing on, I will be passing certain variables into it. Okay. So I made certain changes to this file, to the script, and now it expects Okay, so now this file expects certain variables to be passed to it. So let's say I'm passing a variable, first name is Sahil, Sahil Samir. Now when I run the script, okay, it again is asking for my name. Now the first variable that I passed, if I compare the output with the file now, so file name $0. So the $0 is a special variable that prints out the file name. My file having had name test.sh, so it printed out the name correspondingly. The first variable that was passed to the script can be accessed using $1. The second variable by $2. So similarly, the nth variable can be expressed by $n. Now, if you want to print out all the variables that were passed, you have two options. One is you can use $, otherwise you could have used $. So these are variable specific. So whatever variables that you pass to a script, that can be accessed using the $n notation. You can say the $n notation. $hash will print out all the arguments. Will print out the number of arguments. Sorry, I didn't use that into the script. So this had two arguments. So $hash will print out the number 2. And if you want to individually access those arguments, you could use $n. Otherwise, if you want to access all those arguments, you could use $* or $@. Now there is a slightly difference between a $*, although they look same. So both of them printed out same things in here, but they are little different when it comes to writing a loop. For example, if I am writing a loop for I in, okay, before discussing that, let's discuss about the array variables first. So if you want, so right now, whatever values I was storing into a variable, I was actually just able to store a single value. So if this variable var was only able to store a single variable, a single value like this. And if I want to add another value, it doesn't add up, but it just changes the value of the older that was earlier present in this variable like this. But if I want to create a container that can hold multiple value, such a container is known as an array variable. And in this kind of a variable, I could have placed multiple values like this. Now, if I want to access the value associated with it, definitely I could have used $sign, but now what you can see is, sorry, I didn't place an echo, but now you see is just passing the variable name or actually print out only the first value. But if you want to print out the other values, you could have done something like this. So we'll have to place it into parentheses followed by the index. So this is a 0th index, this is the first index, this is the second index. So if I want to access the test value test, I would give the index 2. If I want to access the value Samir, I would give an index 1. If I want to access Sahil, I would have given the value 0. And similarly to how $* is used to access all the variables, I could have given it a value star that will give me all the variables, all the values of this array. I could have also used the variable at. Now, the difference I was discussing in these two things is basically when you write a for or when you write a looping situation. So let's say I want to iterate over all these values. one by one, and I'm using a for loop for that. So for I in, if I would have used this thing, now there's a catch that this difference can only be accessed when you use these variables within these quotes. Otherwise, you won't see any difference between these two. Now, if I want to iterate over each of these values, and if I use a star thing, and let's say I print out the value of each iteration, you can see that the star actually considered everything as a single variable. So this whole thing it considered as a single variable. But if I place @ in here, now every variable is considered as a separate, every iteration is considered as a separate value, and it print out as a separate thing. So this is the difference between @ and star. When you're working on iterations and when you are using it within quotes, the $* is a special parameter that takes the entire list as one argument with spaces between them. So it has taken this entire list as one argument with spaces between them, as you could see in here. But $@ is a special parameter that takes the entire list and separates it into separate arguments. So every value is considered as a separate argument when it comes to $@ symbol, like this. Okay. So this thing I think is the basic understanding of scripting: variable, container, array. Then there comes something known as looping. Arithmetic operators, Boolean operators. So this is all happening over the variables. Okay, so everything is happening over a variable and its value. You have operators, Boolean, arithmetic, negation, and or, and then you have similar operations over string variables as well. Then you have certain file test operators. If you want to check if a file exists, you can use this variable, you can just use this operator. So you have all such operators like this. And then comes the normal scripting commands that you have already worked on to: mkdir, touch, cat. So all of these commands you can use within the script as well. And then there's this something known as conditional statements. So if certain value satisfy, then this condition would work. So you have if else, switch case, something like that. And finally comes the looping statement, one of which I have already discussed about for loop, like this. You could have other looping also, like while loop, case statements, and things like that. So this will be the basic understanding of scripting. And once you are through with it, just try to create certain scripts. So try to practice all such things, all these variables, how they actually work. And then once you are through with it, whenever you are working on a org project or anything, always try to create a script out of it. So let's say this installation of Cloudera that we did, the Cloudera cluster creation that we did, try to write all those steps within a script and make that into a script file instead, so that whenever you want to create a cluster, every time you don't need to come back to that document and run those commands one by one. Instead, or you should have all those commands summarized into this script file, and that when you run this script, it automatically creates the cluster for you. This is like an automation thing. Okay, so scripting helps you to automate stuff, and always it's my recommendation that any project, any task that you do, always think it in a perspective that you might have to do it in future also. So whenever you are doing that task, try to note down those steps into a script file, and you know make sure that that file works, so that in future if you want to create such thing again, you don't have to restudy all those commands. Instead, you just have to run the script and automatically everything comes up fine. So this was a basic introduction. I wanted everybody to know scripting. I've already done this with earlier batches also. And the next step for you is to uh, automate your cluster creation using a script. Any doubt, guys, before I wind up? Okay, just go over this, and I would want, as soon as possible, you can automate your cluster creation. It might take some time, but create a script out of all those steps, and let's let's see who does it first, who can give me that script that will automate my cluster creation in future. And make sure that that script, I can pass a variable that determines the version of the Cloudera that I'm deploying. Okay, so depending upon that version, the script would automatically deploy that cluster for me. So you can give it a try, give it a hands on, and let's see who does it first. Till then, let's call it off. Any questions you still have on scripting? Also, refers to various things available on the internet about Linux commands. So all of this, apart from this, is you have Linux commands that you can include within your scripts. You can also write a Python script instead of it, and you can include your shells commands into that. So you can study about that too. But all in all, this is a basic requirement you need to understand about variables, about iterations and stuff. And once you're through it, you can make your knowledge go ahead and make it more advanced. Okay, guys, let's calling it off. Any doubts you have, you can just come up to me on the WhatsApp group. Good night and goodbye.